Okay, so for this video, we are going to discuss the May-June 2022 paper 1-1. Alright, so let's start with the first question. Okay, so for the first question, they give us a quadratic expression and they want us to rephrase it into the completing square form. Alright, so this is the completing square form. Basically, when we want to completing the square, we need to plus. Okay, so you need to plus something square and minus something square. Okay, for the quadratic expression. Okay, so what's the something here that we should put in? So the something here, basically it depends on the number here, the value, the coefficient of the x. So the coefficient of the x here basically is -8, right? So for -8, you need to divide it by 2. So you're having -4. Right? So that you can actually combine these first three terms together, become a bigger bracket. And we should have x minus 4 squared minus square the 4, you'll get square the 4, you have the 16, and then plus 11. So if you try to simplify this, we'll have x minus 4 squared minus 5. Therefore, from here, you can see that the value of p is actually equals to -4, and the value of q will be equals to -5. Right? Then let's proceed to part number B. So from here, they said, hence, find the exact solution of the equation x squared minus 8x plus 11 equals to 1. So the word hence tells us that basically we can use the result in this part number 1, part number A, to replace it in our part B. Basically, x squared minus 8x plus 11, we can substitute it by using the result that we get in part A, where it should be equals to x minus 4 squared minus 5. And we let it equals to 1. So continue from here, we will want to solve the equation and get the exact solutions. Right, so I move the 5 over. I will have a 6. And I bring the square over become the square root. I will have plus and minus 6. Next step, I will bring the -4 over become a plus. Therefore, you can see that the value of x that we can take, there are two values here. The first one will be 4 plus square root 6, and the other value for the x will be 4 minus square root 6. Okay, so let's continue with question number 2. So for this question, they tell us that the 13th term for an arithmetic progression is 12. Alright, so basically for this statement, we can write out one important formula where we can write out T13 should be equals to 12. And we would like to substitute the formula for the 13th term of an arithmetic progression. So the formula for the arithmetic progression will be Tn equals to a plus n minus 1d. Right, so we would like to substitute it into our equation here. Okay, so T13. A, the first term, we actually don't know what is the value. And then plus n. N for this case will be the 13. So we are having n minus 1, which is 13 minus 1, and I will have a 12. The value of d we also don't know yet, so we can just put it as a d, and I get it equals to 12. Alright, so from here, I actually get my very first equation. So maybe I would like to make the a as a main object, so I'm having 12 minus 12d. And this one, I will put it as a first equation. Okay. And if we continue further, you can see that the sum of the first 30 terms is -15. So from this statement, we can write another important equation where the sum of the first 30 terms should be equals to -15. Alright, so according to the formula of the sum for the first n term in the arithmetic progression, it should be n divided by 2 and then 2a plus n minus 1d. So n again is 30, so n minus 1 becomes 29d. And it is equals to -15. Okay, so I would like to simplify this before I can solve these two equations simultaneously to get the value for a and also d. And if I continue further from here, then what will I get is I will get 2a plus 29d equals to negative 1. So I will make this as a second equation. Alright, so since I'm having the first and second equation here with the unknown a and d, I can use them to solve them simultaneously to get the value for a and b. A and d. Alright, so I will substitute 1 into equation number 2. So when I substitute equation number 1 into 2, I will have 2a. I will replace it by using 12 minus 12d plus 29d equals to 1. Okay, so if I continue further from here, I'll have 24 minus 24d plus 29d equals to 1. Okay, so if I continue to simplify all this, eventually I'll get my value of d, which is negative 5. Right, so once I get the value of d, which is negative 5 already, I can substitute this value into my first equation to get the value for a. Alright, so if I substitute it, the value for a that I get will be negative 12 minus negative 5, multiply with negative 5, and then plus 12. So if you didn't do any careless mistake, the answer for a should be 72. Okay, so this is the value for a and d that we get. And if we look back to the question, basically they want us to find the sum of the first 50 terms of the progression. Okay, so I would like to use these two values that I find out here and to get the sum of the first 50 term. So to get the sum of the first 50 term, it will be n divided by 2, 2a plus n minus 1 become 49, and the d is negative 5. So by pressing calculator, if you didn't do any careless mistake, then the answer that you get should be negative 2525. Right, so question number 3 is given that the coefficient of x power 4 in this expansion is a, and there's another expansion, the coefficient of another expansion, x squared, in this expansion is a b. So they want us to find a and b in terms of the constant k. So we'll start with the first bracket first. Alright, the first expansion. Alright, so for this particular expansion, the general formula to get any specific term, it will be find c r and then 2x squared power 5 minus r and k squared divided by x power r. Alright, so there are many ways for us to decide the value for r. Okay, so we now want to focus on how to get the x power 4. Okay, so for me, I'm using some simple trial and error method where I try to input some value of r and then try and error to see whether I can get x power 4 or not. Alright. Okay, so if I want to get x power 4, if I put r equals to 2 here and also r equals to 2, okay, so the power here for 5 minus r will become 3, right? Okay, so when you're having x power 2 power 3, in overall you're having x power 6. For this one, 1 over x, when you square it, you have 1 over x squared. So x power 6 divided by x squared, you have x power 4. So you can try and error the power slowly, okay, to get the power that you want given in the question. Alright, so of course, this is the one of the method that if you don't want, then you can let the power, total out the power, which is equals to 4. Then from there you can decide that the value of r should be a 2. Okay, so there are many ways for you to solve it. So for me, I'm using the try and error method. Right, so after the try and error method, right, I know that this is power 3 and then this one will be power 2. Okay, and I let it equals to ax power 4. Okay, so try to get all the values here by using calculator. Okay, so 5c2, I will get 10. Right, then 2 power 3, I get 8. X squared power 3, I get x power 6. Then I'm having k power 4 here divided by x squared. and I let it equals to ax power 4. Alright, so now I try to multiply every terms here, okay, every brackets here. Eventually I will get 80 k power 4, then x power 4, and it is equals to ax power 4. So by comparing the coefficient for x power 4, you can see that a can be written as 80 k power 4. So this is what we have for the A. And now you want to proceed to B. Okay, so to get the B, I will want to expand this. And I'm looking for the coefficient of x squared. Alright, so to get the x squared again, I can try and error the power to see what is the power that I should put in so that I can get the coefficient with the x squared. Alright, so basically to get a 4, I might have 1, 3, or 2, 2, or 3, 1, and so on, right? Okay, so I think quite obvious lah. For this example, I need to put it as 2 and 2 so that eventually when I simplify everything, I'll get x squared. Alright, so the number here will be 4c2 as well. Okay, so again, try to press calculator and then expand everything and simplify it into x squared. Okay, so if I further simplify, I will have actually 24 k square x square, and it is equals to bx squared. So very obvious also, b here, compare the coefficient with the coefficient. Right, so compare the coefficient with the coefficient, you can see that b is actually 24 k squared. Right, so this is the answer for A and also the answer for B. Alright, okay, then we can proceed to the next part, part number B for this question. Okay, so for part B, they are saying that given that A plus B is equals to 216, find the possible values of K. Alright, so it is given that A plus B equals to 216. Okay, so first of all, definitely we need to put in okay, the result that you get in part A. Alright, so what is the A in terms of K? A is actually 80 k power 4. What is B actually? The B will be 24 k squared. And then I bring the 216 over, become negative 216, and it is equals to 0. So from this equation, right, basically it is a quadratic form equation where you're having x power 4 and also, k power 4 and also k power 2. Okay, you can see that this is a quadratic form equation. Okay, so maybe before I solve the quadratic form equation, I can try to simplify it first. I divide all the coefficient by 8. So I'm having 10 k power 4, then 3k squared, and also minus 27 equals to 0. Next step, I try to factorize it, just like how you factorize a quadratic equation. For the 10 power 4, 10k power 4, maybe I can split it become 2k squared and also 5k squared. And then for the 27 here, I can put it as negative 3 and 9, I think. Negative 3 and then plus 9. So I double check. 5 times 3 is negative 15. 9 times 2 is positive 18, right? Then I get a 3k squared, which is correct. Alright, so continue from here. I'm having k squared equals to 3 over 2. K squared equals to negative 9 over 5. So I think for this part of the answer, we need to ignore it because when we take square for the negative value, it will be a math error. Then we come back to the first part here. Okay, so I can further simplify this one. So when I want to find out the value for k, I should take square root. Alright, so it will become plus minus square root 3 over 2. So this can be your final answer. Or if you want to rationalize your answer, then it will become square root 6 over 2. So both answers are accepted here. Alright, so this is how we solve question number 3. Okay, so now we come to question number 4. The they want us to prove the identity that shown here, right? Okay, so basically if we have a look for both sides, right? For left hand side we are having two fractions, and then for the right hand side we are having one big terms. Okay, so in our practice, I think it will be good. We can start the proving part from the left, because to combine two fractions become one is easier. Alright, so we will start from the left hand side. Okay, so left hand side we are having this expression. Okay, so sine power 3 divided by sine theta minus 1 sine square divided by 1 plus sine theta. Okay, so definitely for the first step, you need to try to combine these two terms together. Okay, so if I want to combine these two terms together, right, we can cross multiply and combine the fraction together. So before I cross multiply them, what I want to do is like I will want to change this 1 plus sine theta, rephrase it becomes sine theta plus 1, which is still the same, right? Okay, so when you try to combine these two together, and now I want to multiply the denominator to each other, and also cross multiply what we have on top. Alright, so we are having a big fraction here. Try to simplify all the expression, okay, for the numerator and denominator. Okay, so for the denominator, if I multiply them, I'm having sine squared theta minus 1. Okay, then for the numerator, I will try to expand everything. So I will have sine power 4 theta plus sine power 3 theta, then minus sine power 3 theta plus sine square theta. Okay, and from here I think we can see very clearly that sine power 3 and sine power 3 can be cancelled off with each other. And then for the numerator, I'm having sine power 4 and sine power 2. So we can actually factorize out the sine square theta for this case. And then I'm having sine square theta plus 1. Okay, then now we come to the denominator. I'm having sine square theta minus 1. According to what we have in our answer on the right hand side, right, our expression must have something with tangent. Okay, so to get the tangent at the denominator here, it will be good if we can have cos. So that sine over cos, I will get something related to tangent. Right, so for the for the denominator here, alright, so you can actually try to use the identity that we learned before, which is sine squared theta plus cos squared theta equals to 1. And if you try to rephrase it, you will get sine squared theta minus 1 equals to negative cos squared theta. So we are going to use this result and substitute in my next step. Alright, so I'm having negative cos squared theta here. Then I think for next one, you can see the answer appear very clearly. Okay, if I try to combine this part together, sine square theta divided by negative cos square theta, I will have negative tangent square theta. And then followed by sine square theta plus. Okay, so this is how we prove this identity from the left hand side to the right. Okay, so now let's continue to part B. Okay, so for part B, they want us to solve the solution. Okay, solve the equation for this one. Okay, if we try to compare, right, you will realize that this is actually the same expression. Okay, that they want us to prove the identity in part A. Alright, so that means I will actually use the result in part A and substitute it here. Okay, so what's the result for part A for this left hand side? So basically for this left hand side, it will become negative tangent square theta and then sine square theta plus 1, and equals to the left hand side, which is tangent square theta, then 1 minus sine square theta. Okay, and then next we are going to try to simplify all this. For this whole term here, I will bring it over and the negative will become a plus. So if I rewrite my whole equation again, then I will have something like this. Okay, negative become positive, so I'm having positive square tangent square theta and then sine square theta plus 1. Okay, so to solve this equation, right, I need to further factorize this equation. Let's say this whole thing is the first term, this whole thing is the second term, so I can actually take out a tangent square theta from the both first term and second term. So the first term left 1 minus sine square theta, second term will still have sine square theta plus 1. Again, if I try to simplify all this, eventually my equation will become 2 tangent square theta equals to 0. Okay, so further solve it, further simplify and to solve it, right? I'm having tangent theta equals to 0. When I bring the 2 over, when I take the square root, it is still a 0. So tangent theta equals to 0. So what's the value for theta that I can have here? So please take note that for this question, they want our solution from 0 until 2 pi. Okay, so to have the tangent theta equals to 0 from 0 until 2 pi, basically our tangent graph will look something like this. Okay, so I hope that you still have the idea about the tangent theta. Alright, so basically the graph, the diagram or the graph for the tangent will be here, will be something like this. So you can see that to get a 0, okay, it will 0 when x equals to 0, when theta equals to 0. And then the y is equals to 0, tangent theta equals to 0 when the x is equals to pi over 2. This is not pi over 2, pi over 2 is asymptote. So this value itself should be pi. Okay, so I'm having 0 and also pi to get tangent theta equals to 0. So my theta would be 0 and pi. Alright, so this is how we solve this question number 4. Okay, so we come to question number 5. Alright, so they give us a diagram and then we have the sector ABC of a circle with the center A. So this A is a center lah. Alright, and the radius R. Okay, so the line BD is perpendicular to AC and the angle CAB is theta radian. Alright, so for part A, they are saying that the theta is pi over 6. So they want us to find the exact area of BCD in terms of R. Okay, so hide the word exact area. Okay, so basically they want us to find this area in terms of R. Alright, so this is the area that they want us to find. And then to make sure that our final answer, right, having everything in terms of R, basically we need to know, okay, all the length, alright, of all the of all the sides, right, all the length of the sides need to be in terms of R as well. Okay, so since they are telling us that the theta is equal to pi over 6, okay, so we will want to look at this particular triangle here. This is a right angle triangle, right? Okay, so for this right angle triangle, you can actually find out the length for BD and also AD, okay, using some properties on the right angle triangle. So as an example, if I'm looking for sine theta, which is sine pi over 6, and for the sine pi over 6, it should be the opposite length divided by the hypotenuse. So the opposite length will be BD, hypotenuse will be the R. Therefore, from here, you will get your BD in terms of R, which is R sine pi over 6. Okay, so the value for sine pi over 6 will be sine 30 degree, and it is actually equals to half. So I'm having BD equals to half R. Okay, so this is one of the important information that we can get from the triangle. Okay, then next we are going to get the length for AD. So to get the length for AD, again, it will be cos pi over 6. Because for cos pi over 6, we are getting the adjacent length, which is AD, divided by the hypotenuse again, which is the R. So from here, you also can get AD in terms of R, where AD equals to R cos pi over 6. So cos pi over 60 will give us a value which is square root 3 over 2R. So after we getting these two length AD and BD in terms of R, then we can proceed with the area of BCD. Okay, so to get the area of BCD, if you have a look from the diagram, basically you are using the sector area minus the triangle area. Then you'll get the shaded area that we want. Okay, right, so let's continue further. Okay, so to get the area BCD, we are using the area of sector ABC for your understanding. All right, so I write out minus the area of the triangle ADB. So this is a right angle triangle. Okay, so formula for the area of sector ABC, in general formula it should be half R square theta, right? So for our case here, the formula should be half R square, then theta will be pi over 6. Okay, then minus the area of triangle ABD, so it will be half base times height. In this diagram, the area of triangle ABD will be half multiplied with the base. The base can be either BD or AD like anyone. So you can write as half R. And then multiply with the height. So if your base is BD, then the height will be AD. So the AD will be square root 3 over 2R. Okay, so we try to simplify from here. Alright, so we are having pi over 12 and then R square, then minus square root 3 over 8 R square. This can be your answer, or if you want to further simplify it, then you will get R square with pi over 12 minus square root 3 over 8. Okay, so this is basically the area of BCD in terms of R. Right, okay, so we can proceed to part B. Okay, so for part B, now they give us some extra information. Alright, so given instead that the length of BD is equals to square root 3 over 2R, find the exact perimeter of BCD in terms of R. Okay, so again, if we go back to the diagram just now, they want you to find the perimeter. So to find the perimeter, let us forget about the data value that they give us just now. Okay, so now they already tell us that the length of BD is actually square root 3 over 2R. Right, so this one is square root 3 over 2R. This is the length. Okay, and then of course we need to add the length for the arc BC and also to add for the length for the CD to get the perimeter. Okay, alright, so now for the part B, I try to write the solution here, okay, so that you can see the diagram clearly. Alright, so again, I will want to use the triangle again, right angle triangle, to help me and figure out the data first. Okay, so from here, part B. Okay, so to get the data, I will have ABD is the opposite length from theta. Therefore, I'm having sine theta can be written as square root 3 over 2R divided by the hypotenuse. So again, the hypotenuse will be the R. So when we simplify, we are having sine theta equals to 3 over 2. And from here, we can actually get the value of theta, where the value of theta will be equals to 60 degree. So 60 degree will be pi over 3. Okay, so once I know the degree already, this is pi over 3 now. Okay, so we can actually try to start with the perimeter of the sector that they want us to find. All right, the area that the segment that they want us to find. Okay, maybe we need to find out AD also. Alright, so find out AD so that later I can use it to find out the CD. Alright, so how can we find out AD? So again, still using the same triangle that I showed you just now. Since we already know that the theta is equals to pi over 3, right? So from here, you can form one equation about the cos. So if let's say I'm having cos pi over 3, it will be equals to adjacent length AD divided by the hypotenuse R. So what's the AD here? AD will be R, then cos pi over 3, and the AD value will be half R. Okay, alright. Then now, we will continue to find out the perimeter for BCD. Okay, so the perimeter for BCD will be equals to, okay, so the first length that we have is this one, right? BD. So BD will be equals to square root 3 over 2R. Then plus the length of the arc BC. So the length of the arc BC is actually part of the sector, okay, ACB. Right, so to find the length of the arc for the sector, it is R theta. So R is still the R, the radius, and the theta we already found out just now, right, which is equals to pi over 3. So the theta will be pi over 3 in this case. And then plus, now I want to look for the length for CD. So the length for CD basically is R, the length of the radius, minus the length for AD. So minus the length for AD, we get it just now, which is half R. From here, we can try to simplify all the terms. Alright, so you can keep your answer like this, or you can combine them together by factorizing out the R. Okay, so this is basically how we actually get the exact perimeter for the B, C, and D. Okay, so question number 6, we are given the function, and then the domain for the function is x greater than 2. They want us to find an expression for f inverse x. Okay, so to find the f inverse x, basically you can let y equals to the function, and after that you can try to rephrase your answer x in terms of y. Alright, so we will let y equals to x squared minus 4, then divided by x squared plus 4. So I'm going to try to rephrase my equation here become x in terms of y, right? Okay, so this is what I have for now. I bring the x squared plus 4 up, then I try to expand it, and always keep in mind that we want to group all the x at one side. Okay, so to group all the x at one side, I'm having 4y plus 4 equals to x squared minus x squared y. Okay, then I can further factorize out the x squared. I'm having 1 minus y, and move everything together to the right hand side or to the left hand side. Just keep the x squared at one side. Okay, and then if I want to take square root to get the value for x, I have to consider both plus and minus sign. And if I further simplify it, I will have 2 square root y plus 1 divided by 1 minus y. Okay, so this is currently what we have lah. And basically we need to try. Okay, we need to know, should I consider the final answer as a positive function or negative function here? Okay, so how to decide the positive or negative function? Basically, this one will be the range of the inverse function. Okay, so the range for the inverse function, basically we are looking at the domain of the function. Okay, so for the domain of the function, they're asking for x greater than 2, where definitely it will be a positive value. Therefore, for the inverse function, we should also choose the positive value or positive function. So to get a positive function, very obvious, we are having the plus sign. Okay, so to write the correct final answer for the inverse function f, basically it will be 2 and then square root of x plus 1 and also 1 minus x. And this is how we find out the inverse function. Okay, then we can proceed to part 2. Okay, so for part number B, they want us to show that this expression can be expressed as this one. And after that, we need to state the range of f. Alright, okay, so if they give us 1 minus 8 over x squared plus 4, and we would like to change it become one fraction, basically we are going to make the denominator the same. And after that, we combine them together. If I make the denominator the same, I will have x squared plus 4 as the denominator. And for this one, I will multiply it with x squared plus 4. And then minus 8. And this is how we get the expression that they want us to show. Okay, and actually they want us to state the range of f. Alright, so basically we know that this is the fx. Alright, so this is the fx, which means this is also the fx as well. So when they ask us to express the first equation equals to the second equation, right? Basically, if they want us to find the range, you need to use the result that they that they give us. Right, so it will be more convenient if I use this function to find out the range of f. Okay, so to get the range of f, basically I need to know the domain first. So domain, it is given that the domain for the function f, right, it will be x greater than 2. So when x greater than 2, I want to slowly rephrase my inequality become the fx. Alright, so the fx that I'm going to rephrase, right? I want to start from x, I want to get this expression. So that from here I can get my range. Okay, so I will start from x greater than 2, this is a domain. When x is greater than 2, for the next one, if I'm having x squared, definitely I'm having 2 squared, which is a 4. Okay, so I'm having x squared and then plus 4. So when having x squared plus 4, basically you also need to have 4 plus 4, which is the 8. Alright. Okay, and now when they want to take reciprocal function for 1 over x squared plus 4. Okay, if I'm having 1 over x squared plus 4, basically I need to change the sign as well. Okay, besides the 1 over 8, I also need to change the sign for the inequality. So I'm having a smaller here. Okay, so when we take the reciprocal function, right, from the value itself, we also know that when x is greater than 2, 1 over x squared plus 4 will be also always positive. So which means that this expression cannot be negative. So in front, I will have another inequality where it is greater than 0. So this expression basically is bounded between 0 and 1 over 8. Alright, because from here you can see that when x is more than 2, this expression definitely should be a positive value. Alright, so this is how we actually get the other inequality where the expression is more than 0. Okay, so next step again, I need to multiply 8 to the whole inequality. Multiply 8, I will having this, and then 8 over x squared plus 4. Multiply 8, I will have a 1. Okay, and after that, if I want to take 1 minus 8 over x squared plus 4. Okay, so let's imagine if I take 1 minus 0, I will get a 1. If I take 1 minus 1, I will get a 0, right? Or if you want, you can slowly rephrase it again. I multiply the negative. Okay, so when I multiply the negative, I need to change the sign of the inequality and also multiply the negative to the whole inequality, where the 1 will become negative 1, 0 will still become 0. Okay, so if I rewrite it again, it will look something like this. Okay, so for the last step, you need to plus 1 in front of your whole fraction here. So negative 1 plus 1, you get a 0. Then when you plus 1, you are having this expression. Then 0 plus 1, you will have a 1. So I think it is quite obvious that now you are having this as a function fx, and it is bounded between 0 and 1. And this is actually how we get the range for the function, and you can write it out as the function is bounded between 0 and 1, not inclusive. Right, because our value for our domain also didn't include the value 2. Okay, no equal sign. Therefore, our range here will be also bounded between 0 and 1 without the equal sign. Okay, so this is how we apply and try to find out the range for the function f slowly. Okay, so if this is one suggestion, some of us might, or some of you might have some other method to solve for the range. Also, you can apply it. All right. Okay, so let's continue to the part C. Okay, so there's a part C here. All right, so they are asking why the composite function ff cannot be formed. Okay, so basically they are talking about the composite function for this case, right? Composite function. And then the composite function ff. All right, so if you have a look for the arrow diagram of the composite function ff, basically it will look something like this. Okay, so from here to here is function f. From here to here is also function f. Alright, so for this particular diagram, right, this particular set, it denotes the domain of f because you're having the function f, so the set of x will be the domain, right? Okay, so the domain of f of the function is given x greater than 2, and the range of function basically is between 0 until 1. Correct or not? This is what we get in first part and the second part. Okay, but at the same time, for this second set of value, it is also denotes the domain of the function f when you want to have the second function f composite with the second function f here, right? So at the same time, this circle or this set will actually having the also denote the domain of f where it should be x greater than 2, and for the last set of value here, it will be the range of f where it is equals to y between 0 until 1. Okay, then now once we have a look for all the domain and range here, basically you can see a contradiction in this part. Alright, because for this part, if you have a look, this particular set of value should have the value of either between 0 until 1 or x greater than 2. Alright, so you can see that these two sets, when we try to compare them, they are actually not the subset of each other. Alright, that means x greater than 2 does not lies inside the 0 until 1, or 0 until 1 doesn't lies inside the x greater than 2. So this is a reason why we actually cannot have the composite function ff. Alright, so you can make some simple explanation on this. So you can say that the domain of f okay, which is x greater than 2, right, does not lies in the range of f, in the range. Okay, so where the range of f is between 0 until 1. Alright, so that's the reason why the composite function ff cannot be formed. So this is how we can explain them by looking at the arrow diagram for the composite function. Okay, so this is where or how we solve the question number 6. Okay, so question number 7. Alright, so they give us a diagram and they tell us that the diagram show the curve with this equation and also the line with this equation. Alright, so the curve and the line intersect at the point A and B, and they want us to find the coordinate of A and B. Right, so when they want us to find the intersection point, basically you need to solve these two equations simultaneously. Alright, so for the first equation, we are having 3x minus 2 power half, and we let it equals to half x plus 1. So we need to actually solve this equation simultaneously. Alright, okay, so let's start. I want to get rid of the power half, therefore I need to square the whole equation. So when I want to square the whole equation, it will look something like this. Okay, so next step, expand the quadratic equation here. Quadratic expression on the right hand side, I'm having 1 over 4x squared plus 1 over plus x and then plus 1. So I expand fully the quadratic expression on the right hand side. Okay, then next I try to group all the equation to the left or to the right also can, no problem. Alright, so as long as after you simplify and express and put everything on the left hand side, you should have 1 over 4x squared, then minus 2x plus 3, and it is equals to 0. So I think it is quite obvious that you can see we are having a quadratic equation here. Alright, so for this quadratic equation, basically we need to factorize it and to solve it. Okay, so before I can solve it, I will want to get rid of this fraction 1 over 4. So I might multiply the whole equation 4. Okay, so I'm having negative 8x, then plus 4 times 3, which is 12, and it is equals to 0. So continue from here, I can further factorize it. 2 and 6, I think. So negative and negative. Yeah, okay, so I'm having x equals to 2 and then x equals to 6. Alright, so when x equals to 2, if I want to get the coordinate for the y, you can substitute either into this first equation or you can substitute into this second equation here, up to you. Alright, okay, so I'm taking 2 divided by 2 is a 1, 1 plus 1 is a 2. And then for x equals to 6, I also substitute into the linear equation here, and I'm having 3 plus 1, which is equals to 4. So from here, basically we can observe and get the value for the coordinate A and B, which are the intersection points. Alright, so for the coordinate for A, it is at the earlier part of the graph. Therefore, it should be 2 and 2. And then for the B, it will be 6 and 4. Alright, so this is basically how we find out the intersection point by solving the simultaneous equation. Okay, alright, then let's proceed to part B. Okay, so for part B, they actually want us to find the area of the region enclosed between the curve and the line. Okay, so again, if you go back to the diagram here, you can see that the area enclosed is this area, which is a very small area. So basically, it is covered by two curves, or maybe a curve and a line. Alright, so when the area is covered by two curves, basically you need to know where the area starts. So this is the point where the area starts, it will be a 2. This is the point where the area ends, and it will be equals to 6. Okay, so the 2 and 6 basically you already found out in part number A just now. Alright, then you can see that the curve itself is a higher curve, and then the linear function is a lower function, okay, in this area, in this range. Alright, so therefore, if I want to find out set up the area for the shaded region, okay, so basically it is like this. Alright, so to find the area, I know that my area start from 2 and end at 6. So the lower limit will be 2, the upper limit will be 6. Okay, and they are bounded by two curves, right? The higher curve is actually the square root one. So I'm having 3x minus 2 power half. Then minus the lower function, which is half x plus 1. Okay, so we can slowly apply the integration here and substitute the limit. Alright, so to integrate the first bracket here with a power 2, okay, you can copy back the bracket, power plus 1. When power plus 1, you get 3 over 2. So you need to divide it by the new power. And after that, you differentiate the thing inside the bracket. Differentiate 3x minus 2, you get a 3. And of course, you still need to substitute the limit in, which is 6 and 2. Okay, then minus, for this particular equation or expression, you can integrate it slowly, term by term. So integrate half x. Eventually, you'll get x squared divided by 2 and divided by 2 again. So you're having a 4. Okay, then integrate 1, you have the x. And of course, you also need to substitute in the value for 6 and also 2. Alright, so before I substitute any value inside this expression, right, I usually prefer to simplify all my unknown first. All my constant first. Right, so if I try to simplify this constant, basically I'm having 2 over 9. And after that, I'm having 3x minus 2 power 3 over 2. Okay, and later I want to put in the value for 6 and 2 lah. Then minus, for this part, basically you can straight away substitute the value in. So 6 squared, substitute 6 here. So 6 squared is 36, divided by 4 you have a 9. So 9 plus 6, basically you get 15. Now you substitute the 2. Substitute 2 here, 2 squared is a 4, 4 divided by 4 is a 1. So 1 plus 2 you get a 3. Okay, so we are almost done. You need to substitute the limit into the first expression here. Okay, so 3 times 6 is 18, minus 2 is 16. So 16 power square root power 3 over 2, right? Basically it is square root of 16 and then power 3. So 4 power 3 you get 64. Then minus, now you substitute the 2. So 2 times 3 is a 6, minus 2 is a 4. Square root of 4 you get a 2, 2 power 3 you get 8. And then for the second part here, you can simplify it. Okay, so if you didn't do any careless mistake here, basically your final answer should be 4 over 9 for the area that is enclosed by the curve and also the line. Alright, so this is how we solve question number 8. So we come to question number 8. Alright, so we are having the curve y equals to sine x is transformed to this curve y equals to 4 sine half x minus 30. They want us to describe fully the sequence of transformations that has been combined, making clear the order in which the transformation are applied. Alright, so when we're having the x and the y, right, we should, maybe you can try to focus on x first. Alright, if we are having the transformation that is having x and y together, right, which order, it doesn't matter. But for this one, it is quite clear that we can see in x direction, we are having two different transformation here. Okay, one is the translation, another one is the stretch. Okay, so for anything inside the x, inside the bracket, inside the basic function sine x, the sequence that we have should be in the opposite order. That means when we are having half x minus 30, the first one, okay, we let it equal to 0. So the first step is basically we are having a translation first. Because when you are moving the 30 over, this is the first translation that we have, followed by stretch. Alright, okay, so when you want to write out the transformation, basically the first one we will start from the translation in the direction of x. So I will write it in this way, a translation, okay, to the right hand side, because it's positive 30 degree, right? So to the right hand side in x-axis for 30 degree. So that's the first one. Okay, this is the first one. And after that, for the second one is here, we are actually multiplying a 2 to the value of x, where we are having a stretch, right? So a stretch in direction with a stretch factor of 2. That's our second transformation. And after that, you can see that we are actually multiplying a 4 outside the sine function. So when we multiply a 4, it is a stretch in y direction. Okay, so we can write in this way, where it should be a stretch in y direction with a scale factor 4, with a stretch factor 4. So these are the three transformations that we have from y equals to sine x become this new function here. Right? Okay, so we can proceed to part B for question number 8. Okay, so for part B, we're having this. They want us to find the exact solutions. So maybe you can highlight the keyword exact solutions. So our final answer should be in terms of surd form or pi form, cannot be in decimal number. Alright, so for this particular equation. And then the x should be between 0 until 360 degree. Alright, so let's start from the equation given here. I'm having 4 sine half x minus 30 degree equals to 2 square root 2. Okay, first step, we bring the 4 over. When we bring the 4 over, it will become divided by 4. So if I have divided by 4, that means simplify, I will get square root 2 over 2. Okay, and after that, I want to bring the sine over. Okay, when I want to bring the sine over, it will become sine inverse square root 2 over 2. And I will treat it as my basic angle. So my basic angle is equals to sine inverse square root 2 over 2. So for the basic angle that we get, it should be a 45 degree. Alright, and after that, we are looking for the answer for quadrants with sine inverse square root 2 over 2. Okay, so the half x minus 30, right? We are going to find the x later. So now we are going to find this whole angle first. So for this whole angle, we are having basic angle 45 degree. And it is sine positive. So if you have a look here, it will be sine positive. So for sine positive, basically we have to go through the quadrant and see which is the quadrant with sine positive. So basically this is the first quadrant. First quadrant you're having sine positive. So the answer for the first quadrant should be always the basic angle where it is 45 degree. Now we go to second quadrant. For the second quadrant, we are also having sine positive, right? Okay, so second quadrant also sine positive. To get the answer from the second quadrant, it should be 180 minus basic angle. So when I take 180 minus basic angle, it should be 135. Then if you go through the other two quadrants here, we didn't get sine positive value. Therefore, we will ignore the answer from third and fourth quadrant. Right. Then next one, I try to move all the 30 over and also multiply the 2. So if I bring the 30 over, become 45 plus 30, 135 plus 30. And after that, I multiply each answer with 2. I will get 150 for the value for x and also 330 for the value of x. Okay, so I will double check and see whether my answer here actually lies in the range that they give us. So for 150, also 330, if they are actually lies within the 0 to 360. So that means these two answers are the correct answer. Okay, so this is how we solve question number 8. Okay, so question number 9. We are given this equation of a circle. And they want us to find the center, the coordinate of the center for the circle and also the radius. Then find the coordinates of the lowest point on the circle. Right, basically, to get the center and also the radius, right, the method that usually I'm using will be the completing square. All right, and I will want to rephrase it into a standard form. All right, so when I'm having this equation, I will group all the x together first. All right, so to completing square for the x, right, you have to plus something square and minus something square. Okay, so now to get the something square, I'm taking the 6, the coefficient of x divided by 2. So 6 divided by 2, I'm having 3. So plus 3 square minus 3 square. Then next one, I try to group all the y together. So I'm having y square minus 2y. Again, I will add something square minus something square. Look for the value for the something. It should be negative 2 divided by 2. When I'm having negative 2 divided by 2, then I get negative 1. Okay, then what else? We haven't included it here. We are still having the negative 26. And we'll let it equals to 0. Okay, then I will try to take the first 3 terms of the x here, this one, x squared plus 6x plus 3 squared. I will group them become one big bracket, which is x plus 3 squared. Minus 3 squared is minus 9. For the 3 terms of the y squared minus 2y plus negative 1 square, I will group it become y minus 1 square. Then negative 1 square, I'm having negative 1 still, and then negative 26 equals to 0. So from here, if I try to bring all the constant to the other side, I'm having 36. And then if I further simplify it, this is what I will get. X plus 3 square, y minus 1 square equals to 6 square. So according to the definition for the standard equation for circle, your center can be taken out from here, where the x coordinate should be negative 3, y coordinate should be the 1. And this one is actually r square. We'll see that our radius is actually a 6. Okay, so I write out the answer. Center will be negative 3 and 1. Then the radius should be equals to 6. Okay, so we answered the first part of the question already, where we already tried to write out the coordinates of the center. This is the coordinate of the center and also the radius. Then they're asking us for the second question. They want us to find the coordinates of the lowest point on the circle. When we are having a circle, the center is having the coordinate of negative 3 and 1. The lowest point will be somewhere here, okay, which is actually 6 units away from the center because the radius is 6 units. For the y coordinate, I need to minus the 6 to get the lowest point. Therefore, to get the lowest point, the coordinate of x will remain, which is negative 3, and the coordinate for the y, I have to minus the 6. So when I minus the 6, I will get negative 5. That is the coordinate for the lowest point for this particular circle. Okay, then now we proceed to the next part, question number 9b. Okay, for 9b, they want us to find the set of values for the constant k where the line with this equation intersects the circle at 2 distinct points. So to me, this is the keyword to let us to hint us how to start this question. So when I see the keyword intersect, basically I need to solve simultaneous equation for the circle and also this particular line. Okay, so let's start. I'm having x plus 3 square, and I'm having y minus 1 square equals to 36. This is the equation that I have from the first part. I let it as a first equation. Then for the second equation, I'm having y equals to kx minus 5. So this is the second equation. I'm going to substitute the second equation into the first one. Then I solve it simultaneously. Alright, because we want to find the intersection point, right? So we can solve it simultaneously. I will substitute the y as kx minus 5 minus 1 squared. Try to simplify it. Okay, so to get the idea that we are having the intersection point at two distinct points, basically in a quadratic equation, right, we should have b squared minus 4ac greater than 0 because we should have two solutions for the value for x. Okay, from here, we will see that eventually we'll get a quadratic equation. Okay, so we have to rephrase it again. We have to rephrase it into a quadratic equation first before you can apply the discriminant rule here. Okay, so I'll expand everything where I get x squared, 6x, 9. I get k squared x squared, negative 12kx plus 36, and I get another 36 on the right. Okay. Next step, I try to group all the x squared together. I'm having k squared plus 1x squared. I try to factorize and group this x squared and also the k squared x squared together, and I can write become k squared plus 1x squared. Then the next one, I'll group all the x together, where I should have 6 minus 12k x. Simplify all the constant, I will have a 9 eventually. Okay, and now very clearly we can see that we actually obtain a quadratic form equation in terms of k and x. So I want to apply the idea that when the curve and also the line intersect at 2 points, right, two distinct points, basically we are having the rules where b squared minus 4ac should be greater than 0. Okay, so which one is your b? This is our b. This is the a, and definitely this is the c. Substitute inside this inequality. Alright, and again, I will expand everything and we rephrase it again into a quadratic form equation. Okay, expand this bracket, the first bracket here, I'm having 36 minus 144k plus 144k squared. Then for this term at the back, when I expand it, I should have negative 36k squared, then minus 36, and greater than 0. Okay, simplify and rephrase everything again. I'm having 108k squared minus 144k greater than 0. Simplify the coefficient. Eventually, I'll get 3k squared minus 4k greater than 0. So if I try to factorize my inequality, right, I will have 3k minus 4. Okay, so to decide the set value of the k, basically we need to actually consider the number line. Alright, if you want, you can use the number line to help you, or you can visualize yourself to decide. Okay, so I'm having k equals to 0, k equals to 4 over 3. So k equals to 0, k equals to 4 over 3. So this one have two brackets, so both arrow is going to the right hand side because the k, coefficient of k is positive value. Alright, so I'm having plus, minus, plus. Okay, because the line is the positive area, positive, positive become positive, positive, negative become negative, negative, negative become positive. And for our question here, we are looking for greater than 0, where our answer, we should consider the positive side. Okay, so these two are the positive side, therefore the final answer will be x smaller than 0 and also x greater than 4 over 3. Okay, so this is the answer, the range, okay, the set of value for the constant k where the line intersect with the curve at two different points. sorry, I think I make a mistake here. I shouldn't write as x here because our inequality is having k, right? So our answer also should be in terms of k lah. So k smaller than 0 and also k greater than 4 over 3. Okay, so this is how we actually solve the question number 9. Okay, we come to question number 10, which is the last question for this paper. We are given the equation of a curve such that d square y dx square equals to this expression. We are having a stationary point at this point. Okay, so they want us to determine the nature of the stationary point and for this particular point. Alright, is it a maximum point or minimum point? Okay, so previously when you want to determine the nature, basically we are looking for the value for d square y dx square. Okay, so to investigate the nature of the stationary point, we substitute the -1 into the d2y dx square formula. So we're having 6 -1 square minus 4 over -1 power 3. And we're having 6 plus 4, which is a 10. And 10 is greater than 0. So when you're having the d square y dx square value greater than 0, it actually concludes that this particular stationary point is a minimum point. So we should write out the conclusion where this is actually a minimum point. Okay, then proceed to part B. They want us to find the equation of the curve. Alright, so we are having d square y dx square formula. To find out the equation of the curve, basically we have to apply integration for 2 times. That means for the first time we have dy dx. For the second time only we can get the y. Alright, where we need to apply integration from the first stage to the equation of y. Okay, right, so from here we can see that we have to apply integration 2 times to get the value for y. We will start from d square y dx square first. Okay, so let's start. I want to get the dy dx. To get the dy dx, I have to integrate d square y dx square. So what is dxy dx square? I will get 6x squared minus 4x power -3. Okay, so to get the dy dx, if I integrate this term, integrate 6x power 2, I will get 6x power 3 divided by 3, where my power plus 1, and I need to divide it by the new power. For the second term here, 4x power -3, the power plus 1 become -2. So I divide it by also a new power, which is a -2. Then I'm having a plus c at the back. Okay, next step. I'm going to substitute a suitable value here so that I can get the value for c before I continue for the second time of integration. Okay, so to get the value for c, I need all the information here. And I know that just now my stationary point is -1 and also 9 over 2, right? At this is a stationary point, and at this point we will get the value for dy dx, which is equals to 0, because the gradient of tangent should be equals to 0 at every maximum and minimum point for a curve. By looking at all these values here, I can try to substitute the relevant values inside this equation. dy dx, I can substitute 0. 6 over 3, I get a 2. X power 3, I can substitute -1 into this equation. 4 divided by -2, I am having positive 2. X power -2, I'm having -1 square and plus c. So from here, if we try to simplify this equation, basically we will see that the answer for the c is equals to 0. Okay, so once I know that the c is equals to 0, I can continue my second integration to find out the equation of the curve. Alright, so to get the y, I need to integrate dy dx. So to integrate dy dx, this is what we have. I want to integrate 2x power 3 plus 2x power -2. There's no c, right? Because c is the value of 0. My step should look something like this. Then continue from here, I will try to integrate x power 3, power plus 1 become 4 divided by a new power. x power negative 2, power plus 1 become negative 1 divided by the new power, and I have another unknown here. You can write as a c again, or you can write as some other thing else. You can write as a k also here. Alright, so again, by referring to this particular point, I know that this is a point, which is the minimum point, right? And I'm having the value for x and also value for y. Therefore, I can substitute these values into the equation to get the k. Okay, so my value of y will be 9 over 2 equals to, simplify the constant, become 1 over 2, negative 1 power 4, negative 1 power 1. Alright, then from here, if you continue to simplify it, I will have 9 over 2 equals to half, then plus half plus k. Wait, sorry, I think I made a careless mistake. This is not the half, this one should be a 2, right? Because 2 divided by 1, I get a 2. And from here, I will get a value for k, which is equals to 2 actually. Then I rewrite my equation again with the correct final answer. The equation of the curve should be half x power 4 x then plus 2. Right, so basically for this question, we have to apply integration two times for twice. Then only we can get the equation for the y. Okay, then we can proceed to the next part, part number C. For part number C, they are asking us to show that the curve has no other stationary point. Okay, and usually for us, when you want to find the stationary point, we'll need to have a look for the dy dx equation. Right, so I copy again the answer for dy dx that we get just now, which is 2x power 3 plus 2 over x squared. This equation particularly, you can get it from the part B in the solution for part B just now. Okay, so to get the stationary point, we always let dy dx equals to 0. And we are having 2x power 3 plus 2 over x squared. We try to solve for the value of x. Okay, I group. I want to make sure that I try, right? I want to try and see what will I get for the value of x. Okay, I want to group all the x one side, all the number at the other side. So x power 5 equals negative 1. No matter how you take the fifth root, right? The answer for x is still negative 1, which is actually the stationary point that they asked us to, they give us just now. So when you're having only one coordinate for x, it also means that there's only one intersection point for this curve. Okay, alright, then now we proceed to the last part of this question. There's a point A moving along the curve, and the y coordinate of A is increasing at the rate of 5 units per second. Okay, so the keyword here will be y coordinate increasing at the rate. When I see the word rate, that means I know that it is something over dt. So what is the something here? They are talking about the y coordinate of A. For this particular sentence or this particular phrase, I can write out one important formula where dy dt rate, so it is over time, right? So dy dt should be equals to 5. This is the information that we get from this sentence. After that, they want us to find the rate of increase of the x coordinate at the point where x equals to 1. They are asking for dx over dt. Okay, at the moment where the x equals to negative 1. Okay, so from all the information that we get here, right? To write out or to find out the dx dt, I can write out a relevant or related or chain rule, okay, for our calculation. So dx dt can be written as dx over dy multiplied with dy over dt. So how I know that my chain rule should be something like this? It is because of dy over dt is given in the question. Dx over dy, we can get it from our dy dx just now in the second part or the third part. Okay, then next, I want to substitute dx dy into the equation. I need to look at the dy dx that I have first. So for dy dx that I have, I'm having 2x power 3, then plus 2 over x squared. To make our calculation easier for dx dy later, I need to combine these two term become one fraction. So I want to make it become x squared as the denominator. Then for this term, 2x power 3, you multiply with x squared, therefore you have 2x power 5 plus 2. And now I want to substitute this result into my step here. dy dx is something like this. Therefore, dx dy will be x squared divided by plus 2. Okay, and then for this question, they already tell us that x should be equals to 1. Therefore, I'm putting 1 here, I'm having 1 squared. And then 2x power 5 will become 2 multiplied with 1 power 5 plus 2. Then multiply with dy dt. So for dy dt, we get the 5 just now, so I multiply with the 5. Okay, by simplifying this answer, the final answer is 5 over 4 for the rate of increase for the x coordinate. Okay, so this is how we solve the question number 10, and we have completed discussed this particular paper. Alright, so thank you very much for watching.